Hello students, my name is Sanket and welcome back to my world of mathematics in Sanket Sir's Maths Academy. Today let us start the new topic of Basic Proportionality Theorem (B.P.T), also known as the Thale's Theorem. In the first video of the Basic Proportionality Theorem, we will be understanding the different pairs of bases and their corresponding heights for different types of triangles, that is acute angle triangle, obtuse angle triangle and the right angle triangle. So let us start with the acute angle triangle. In the acute angle triangle here, ABC, we have three sides AB, BC and AC with their corresponding heights. Here students, I have marked each side with a different color and their corresponding height is also marked in that same color. So let us start with the base that we see, the horizontal line BC, the horizontal side BC. What will be the corresponding height? The corresponding height of BC will be the perpendicular, the 90-degree line drawn on the line or side BC from the opposite vertex A. So from A, perpendicular on BC is AD. So for the side BC, corresponding height is AD. So let us write that down. For the base BC, what is the corresponding height? The corresponding height is AD. Right? Now, next, consider the side AB. Now, for AB, the corresponding height will be the perpendicular drawn from opposite vertex C. So, from C, the perpendicular is CF. CF is the corresponding height for the side AB. Let's make a note of it. So, for the base AB, so AB is the base, then the corresponding height is CF. What's the third remaining side? The third remaining side is AC. Its opposite vertex B. Perpendicular from B to AC is BE. Therefore, if I consider AC as the base, the perpendicular BE will be the corresponding height. Let's make a note of that. So, for the base AC, the corresponding height is BE. Those are the corresponding bases and height for acute angle triangle. Let us now move ahead with obtuse angled triangle. Now, for obtuse angled triangle, ABC, we see that this angle is obtuse angle. Angle B is obtuse angle, so it is an obtuse angled triangle. We draw the heights or perpendiculars on all sides from the opposite vertices. So, starting with the base AC, I am considering the base AC first. So, perpendicular drawn from opposite vertex B on the base AC with BE. So, I write here as for the base AC, my height is, corresponding height is BE. Now students, pay very careful attention for the other two bases. When I consider the base BC and I try to draw a perpendicular from opposite vertex A, it is going outside BC because it's an obtuse angled triangle. So what I do is I extended the side BC towards the point B and I drew the perpendicular AD meeting the extended BC at point D. So I will say AD is the corresponding height for the side BC. Mind you students, you will not say the side DC because point D is outside. The point D I am taking only as the point for height AD. So I will write for the base BC, the height is going to be AD. And the last side, that is for the side AB. Again, when I try to draw perpendicular from its opposite vertex C, I cannot draw for the current length of AB. So I have to extend AB. I extended AB towards the point B till the point F such that CF becomes perpendicular to AB at point F. Again, the base is not AF, the base is only AB, but the height will be CF. So I will write for the base AB, the height is CF. Students, you might be wondering why we are not considering entire AF as the base and why we are considering only AB as the base. Similarly, when I drew the height AD, why I am not considering DC as the base? Why I am considering only from the point BC as the base? The reason is very simple. Students, consider a particular base or ground here, as I'm showing on the right side. If I consider this particular ground and I have a point in the air, let's say point P. Okay, now this is the ground line, base line. I have to draw, or I have to find the height of P from the ground. This is my ground. I have to find the height of point P from the ground. What will I do? I will just draw a perpendicular straight line from P to the ground, and if I call this point as Q, then the height will be PQ. PQ will be the height. Did it matter where the point Q comes? It's important that PQ is perpendicular wherever that base point Q comes on the baseline or the ground. It doesn't matter. PQ will be the perpendicular for whatever length of the ground. Even if I am considering only this much length, still PQ will be the height, the perpendicular distance of point P from the ground, the height of point P from the ground. So for perpendicular, we have to draw the perpendicular even if we need to extend the base. The original base will remain the same. Quickly repeating that for you. So the base is only BC, but the height is AD. Similarly, the base is only AB, but the height is CF. And now for the last triangle, that is a right angled triangle. Now consider here in the right angle triangle ABC, when we observe, if I consider the base BC, for the base BC opposite vertex A, if I draw the perpendicular, it's already the side of the triangle. So AB is already the side of the triangle. It is the height for the base BC. So when the base was BC, the height was one of the side of the triangle, that is AB. Similarly, if I consider the base as AB, for the base AB, let's draw perpendicular from opposite vertex C. CB is the perpendicular to AB, which means again for the base AB, we already have the height, which is already one of the side of the triangle, that is BC. So I write for the base AB, the height will be BC. This is particularly for right angled triangles, that the two perpendicular sides becomes height and base of each other alternatively. But what about the third side? The third side or the third base that I will consider is AC. For this, we will have to draw a perpendicular from the opposite vertex, the 90-degree vertex, that is point B. I draw a perpendicular, let me call this base point as E. Then I will say BE is the perpendicular or height for the base AC. Now students, if you observe the three triangles, that is the acute angle triangle, obtuse and right angle triangle, you observe that the three heights intersect at a common point. The three heights pass through a common point. Which is that common point? In the first diagram, AD, BE and CF, all three were passing through this common point O. Similarly, in the second diagram, also the height AD, which is outside the triangle, the height CF, which is also outside the triangle, and the height BE, which have extended backwards from the vertex B, all the three heights meet outside the triangle at a common point, and name the point again as O. And similarly, in the right angle triangle also, where do the three heights intersect each other? The height BE, the height AB and the height BC all intersect at the right angled vertex of the triangle, that is the vertex or the point B. So we see that the three heights, which are also known as altitudes, the three altitudes or heights of any triangle are concurrent. What do you mean by concurrent? Concurrent means they intersect at a common point. right? So this was the relationship between different bases and the corresponding heights for different types of triangles. Next, we will see how we find areas of different triangles using the basic formula half into base into height, and we will be taking ratio of areas of two triangles. Thank you for watching this video. Hello students, hope you like this video. More videos about basic proportionality theorem or Thale's theorem are coming up soon. So stay tuned and subscribe to Freebirds Educare